In this video, we're going to go over how to use the density formula in a chemistry classroom. Now, a lot of times you've learned density before in various grades, but typically what the teacher would do is they would give you the density with the units you need in order to do the problem. So you won't have to do any sort of unit conversion. In chemistry, we often get the units where we have a problem in units that we don't necessarily want or need, and we're going to have to convert them into other units. So the one conversion that unfortunately has to be memorized is this one right here. A milliliter is a cubic centimeter, or in the medical world, they call it a cc. Maybe you've heard of that before, but all the other conversions that we're going to do are going to use King Henry's daughter usually drinks chocolate milk. So we're going to use that conversion a lot. So I have three density problems. Each one is basically a level of difficulty. Number one would be like your density problem from like maybe middle school. Number two might be a little bit harder, maybe earth science. And then number three is more along the lines of a chemistry density problem. It just really, the only difference is not the formula, but the amount of extra stuff you have to do with the formula. So the first problem, the way I like to do any math formula in my classroom, and I want to see you doing this, is I always start by writing out a skeleton of the problem, d equals m over v. The next thing I'm going to do, let's read through it. A student determines that a piece of metal has a mass of 100 grams, so I can put 100 grams in for my mass. The volume is 25 milliliters, so that goes in for volume. Notice I'm writing my units in, and then they want to know what's the density. So here's my x. Here's the important part. The units of my density are already determined. They are grams and milliliters. Reason being is because my mass was given to me in grams and my volume was given to me in milliliters. So I do my math and I get x equals 4 grams per milliliter. So there's your first problem. It seems like a little overkill to write all these units out, but as the math gets more advanced and we do larger formulas, you're going to need to start keeping track of things in order to have the right units at the end and not lose points on your units. So it's a good habit to start now. This is the only way I'm going to be accepting things in this class. So let's do number 2. An unknown liquid has a mass, so we know it's a density problem. So always write it out like that. An unknown liquid has a mass of 11 kilograms. I'm not going to write that down yet. The volume is 1,000 milliliters, and they want to know the density in grams per cubic centimeter. So this is what they want. They want my density, or they want density, and they want it in grams per cubic centimeter. Now, what that means is my mass has to be grams, and my volume is going to have to be cubic centimeters. Okay, I need to make those two numbers or units match, and I want those units to match. So since I don't have 11, since I have 11 kilograms, not grams, I can't just plug 11 in here. I have to use King Henry's daughter to turn 11 kilograms into grams. And in this case, kilo is the K, grams is the unit. That's 1, 2, 3 to the right. It would be 11,000 grams. With or without the decimal at the end, doesn't really matter. And then my 1,000 milliliters. That, a common mistake I get a lot is students will look at milliliters and say, well, that's the M on King Henry, and then they'll look at centimeters and say it's the C on King Henry, so let me move it one to the left. The reason that's wrong is because of this. This unit, the base of that unit is cubic meters, and the base of this unit is liters, so we can't do that conversion. That's where this memorization bit comes in. You have to remember that a milliliter and a cubic centimeter are actually the same thing. So 1,000 milliliters is 1,000 cubic centimeters. I do my division, and I'll end up with x equals 11 grams per cubic centimeter. And that's the final answer. Last problem. So they give me the density, 4.3 grams over milliliters. That is going to force me to keep my mass in grams and my volume in milliliters. They want to know, now here's the trick, they want to know the mass in centigrams, which I cannot solve for right now. And then they give me the volume in liters. So if I use King Henry's daughter, 0.25 liters will become 250 milliliters, because I have to go 3 to the right in order to do that. L is liters is the unit and milliliters is the M. And so I can put 250 here, and then I can solve for my mass. So in this case, I make two fractions and cross multiply, right? So I get 4.3 times 250, which is 1,075 grams. They still want the answer in centigrams. So now I'm going to have to use King Henry again and go from grams to centigrams. So I'm going to have to move the decimal 2 to the right. And that is my final answer. Now, we could go a step further and then say, now take this answer and put it in scientific notation. And that's how a single chemistry problem can really tie together multiple concepts. And I will do that on quizzes. I will give you these numbers. Sometimes I'll even put the numbers in scientific notation, where then you have to take them out, use them, convert them, and then put them back for the final answer. So be aware of that. This is our density lesson. There will be some practice problems and an answer key for that as well.